are a few methods to determine cardiac axis. After learning this topic, you will fully understand how to interpret axis of any kind of ECG. It's pretty simple actually. So let's start from the beginning. What is cardiac axis? And why do we need to know it? ECG axis is direction of electrical activity of heart. Since the left ventricle makes up most of the heart muscle under normal circumstances, so normal cardiac axis is directed downward and slightly to the left. Normal axis is when QRS axis between -30 degrees and +90 degree. Abnormal axis deviation, indicating underlying pathology, is demonstrated by left axis deviation equals QRS axis less than -30 degrees. Right axis deviation equals QRS axis greater than +90 degree. Extreme axis deviation is when cardiac axis is between -90 degrees to 180 degrees. Similarly, P-wave and T-wave axis can be determined. Abnormal QRS axis deviation have significant impact on normal ventricular functions. There are several complementary approaches to estimating QRS axis. First of all, we will learn about two-lead analysis method that is the easiest one. The most efficient way to estimate axis is to look at lead 1 and lead AVF. Examine the QRS complex in each lead and determine if it is positive, isoelectric, or negative. A positive QRS in lead 1 puts the axis in roughly the same direction as lead 1. Similarly for AVF. To estimate QRS complex morphology, we need to look at R and S wave. If our wave is greater than S wave, it's positive. If S wave is greater than R wave, it's negative. If R wave equals S wave, the QRS complex is equiphasic. Now, after estimating the QRS complex's morphology, head on to combine the patterns and we will find out the ECG axis. Now, if QRS complex is positive in lead 1 and AVF its normal axis. Right axis deviation or RAD if QRS complex is negative in lead 1 and positive in lead AVF. Left axis deviation or LAD if QRS complex is positive in lead 1 and negative in AVF. And extreme axis deviation if QRS complex is negative in both lead 1 and AVF. Now exercise to determine cardiac axis in following ECG. As the QRS is positive in lead 1 but negative in lead AVF, its left axis deviation. As QRS axis is positive in both leads, hence normal axis. As QRS is negative in lead 1 and negative in lead AVF, its right axis deviation. As QRS is positive in both lead 1 and AVF, its extreme axis deviation or northwest axis. There are also other methods to determine axis. The axis man method given by Blog Life in a Fast Lane is my favorite. You can learn it from link given below. Similarly, three-lead analysis and isoelectric axis method are also complementary to derive axis most precisely.